Thank you, Mads. It's wonderful to be here. This is a fantastic conference. I really hope to blow your minds again. This is, to me, a new idea. And what's interesting is combining two old ideas, getting something really new and interesting and powerful. This talk was condensed from a talk last fall. So look, if you only come away with 3 sentences, we have one per co-author, here they are. We're going to replace the single implicit receiver in standard object-oriented programming with a bunch of things, but they're each playing a different role. And that's going to give us a multidimensional context, which will both organize and control what happens, but the environment will then dance with that complexity and symmetry to produce lower projections that'll help people work in this more effectively. So I'm going to start off with the basic idea, except before the basic idea, you need some preliminaries. Okay, how many people here know something about self? Fantastic. So, being that it's my favorite object-oriented language, we followed self in our thinking about this stuff, but I'm not going to bother you with self-like syntax. It'll be presented in a more understandable syntax, more like C++. And, but because it's prototype-based, we talk about individual slots. State and behavior are unified, so there's no difference between pop with parens and pop without, or accessing a variable either way. And just like what all you're familiar with, the particle of computation is to find a slot and run it. If the slot has data, it just returns those data. But the interesting thing is going to be how that is found. To introduce the diagrams I'm going to use, here's a self stack. There's the object. There are 2 more. In fact, I have labels for you. These things are called slots. The top 2 hold data, the bottom 2 hold code. And there's some code that might use our stack. And I'm going to shorten the diagrams by drawing some of the objects right inside the slots. And, of course, we can have 2 of these things if we want. And we've got inheritance, which is drawn that way. And we can have multiple levels of inheritance. A message sent to one of these stacks, if it doesn't find a matching slot, climbs up till it does, runs the code in the slot it finds, but of course, self, the receiver, is bound to the original receiver. Okay. Now, I'm going to talk a bit about the key insight that led me to this formulation. And this was thinking about the importance of context. In any communication, what we're not saying is really, really important. It has to do with the shared understanding. So when this guy says, go get it to that one, he doesn't have to say every step or exactly what, because they're embedded in a shared physical context that induces a shared mental context. And I think that it's really context that gives all of our languages their power. Let's look a little bit about, in the object-oriented sense, look at how much context there is here. This push routine is in the context of some class or prototype, if you're a selfie. All of these calls in white are in this implicit context of the receiver, but it's not stated. And occasionally, you do something in a different context. That's the yellow. But mostly, you're staying in that same receiver's context. And what's interesting is it kind of fades into the background of your mind. In fact, in languages that we use, this is so much fading into the background that it literally just fades and you don't write it. Now, because we have this context, we get to do reuse. That object becomes a unit of thought and reuse, and it makes evolution a whole lot easier. We can refine objects or classes. We can interpose them. So this context is playing a very powerful role. Now, well, if some context is good, more context must be better. So what we're going to do with these ideas is get more context by going from one of these implicit arguments, called self or this, to a whole bunch. And they have to be implicit to get that power. So what you're going to see, every message send, that atom of computation, will be sent to a tuple of these, what we would used to think of as objects, each playing a named role. Each particle of state or behavior, the slot, will say a bunch of required objects for each role it cares about. And then when we think of the system as a whole, we'll think of it as a whole sea of slots that clump together into what we used to think of as objects depending on the viewpoint or the context. Okay, so let's get there. Let's generalize. Here's our stack again, and I've added an extra piece to the slots that just kind of is linked to the objects that are containing the slots. And the piece has this receiver word there. Now, once I do that, I don't need to put the slots inside the objects. And once I do, because see, they're linked, so we know. And once I do that, these things that used to be objects become just points, just coordinates, just unique identities. Now, a little terminology. This new piece I added is called the slot guard because it guards when the slot is run. So if I send a message to stack 2, SP, I'll get that slot because it is saying I only see that slot when the receiver is that object or a child, and similarly for these. So they're controlling the dispatch. Now, so far all I've done is I've taken self, a nice, clean, simple, elegant, beautiful, wonderful language, and I've tarted it up with a bunch of extra junk in the picture. Okay, here's where it gets interesting. Because I write code with bugs. So here's some code where I'm pushing something on the 2 different stacks, but then I'm popping it from the wrong stack. So at that point, my stack's going to underflow. I'll get a crash up here. Okay, that would be bad enough if I made that mistake. But it's not even my mistake. You know, I've got this code over here that I'm writing in method A, and I'm calling Harold's code, my co-author, and he's calling method C. And method C, I didn't want to use Doug's name for this method here. That's the one with the bug, right? That's Joe's code. So the bug is there. It's not in my code, but I'm getting this crash when I run my code. And what I really want is a check, another pop routine that I use for debugging that, you know, if the stack pointer is underflowing, call the debugger, halt is small talk ease for that, else do the other pop. That's what I really want. And in a lot of situations, I'd have to add a macro or a global, and it gets all kinds of messy. Now, as I've drawn it, we've got this problem that pop is ambiguous. Which pop do I mean here? Well, here's where it gets interesting. Because I've got this piece, I can add another piece, and we'll call this piece debug. And in my debug pop slot, I'll link it to the true object, and in the old one, I'll link that to the false object. Now, all I have to do is set that debug implicit parameter, implicit argument somehow here. Okay, here's a little bit of syntax to do that. This says, by the way, when you call method B, pass it this argument named debug, which is going to be bound to true. Now, this call will implicitly pass it down, because these are implicitly passed parameters, just like self or this is in an old familiar object-oriented language. But now we have more than one of these. We have self or this, and we have debug. And here it gets implicitly passed down. So when we call pop, we're going to find this slot because it's the only one that matches both the receiver and the debug argument. This will do its check. Then it sets the debug argument to false and calls pop, and that'll do the real work of pop. So what's happened here is that pop message wasn't sent to just one object in object-oriented terms. It was sent to a bunch of these things with a name and a value. The name describes the role. I also like to call it the dimension. The value is just a reference to one of these identity things. We call that coordinates a lot of times. And all of those participate in the dispatch. So again, just to be clear, there are the names, debug, receiver. There are the coordinates. That's the things that those things are linked to. Yeah?
Out of curiosity, the debug that's coming through, how does it know when to stop implicitly passing it down the line?
It's just passed all the way down. It's context. It's been established. I'll show you in a moment there's syntax where it can explicitly stop it. Now, on this slide, the point is that a slot doesn't have to pay attention to dimensions it doesn't care about. So when we added that whole debug stuff, we didn't have to change this top one. The example still works, because when we call with debug equal to true, this slot's a better match than that slot. And then once debug is falsified, that top slot's the best match on the page. And here's the thing. If it wants to explicitly remove it from getting passed down, it can. But the whole point is these methods are oblivious to what comes in and what goes out because they're passing down context. And by the way, if you really with me, you know that the old syntax with the dot turns out, or the arrow, turns out to be just some sugar for setting the receiver argument to something. That's all it is. So these things are all symmetric. No one dimension matters more than any other. Now there are a whole lot of uses we can put this to. What we used to think of as the receiver, do I want to run debugging code? How much assertion checking do I want? We could bind that to, say, 3 objects, coordinates, none, fast, and all. How much logging? What version of the code do I want to run in the context of? On whose behalf am I running the code? And all of these can be ignored till the code cares. So, slots are dispatched on multiple dimensions. Slots are no longer inside of objects. Context passed down implicitly. A message is sent to many objects, each in a named role. And here's a really interesting one. How many times have you implemented an ontology, a class hierarchy, or whatever, and then a second kind of variation comes along, and you go, dang, I have to do a visitor pattern. I have to do 2 hierarchies of pluggable objects. I have to do something else. Well, we get rid of that speed bump here because all you have to do is add new slots where it matters that are sensitive to the new dimensions. So growing from one kind of variation to multiple ones has gotten really easy. So let me give you one quick example. And I'll talk about using this stuff for privacy. Here is our stack again. I'm not going to do inheritance for this example. And of course, the problem is any old code can change the stack pointer at will, throw something in the contents, and mess up the integrity of my stack. Okay, so we need to protect it. Most languages introduce public, private, friend, this, that, or the other. We don't have to do that with this model. Let's think about what we really want to protect. Well, one way to think of it is the classical stack invariant, what the size of the stack is, and the elements. You guys all know this stuff. So I'm going to just graphically separate the slots. These over here are the ones that are we don't mess with from outside, otherwise the invariant breaks. These could break it. These there have been carefully programmed to maintain the invariant. Now, in this world, what we can do is we can say that coordinate there is going to represent the invariant. And we're going to guard these slots with another piece of the slot guard in a dimension which we'll call invariant. And now, what's really cool is these slots can only be accessed if this thing is in the context, in the proper role. So, the next step is we will put the syntax in here to say, when I run this code, add that to the context. Now, these slots can access the stack pointer and the contents parts of the stack. And now, if we look here, so far pretty good. This still works that we want to. These things don't work. They won't even see these slots. We'll get, the equivalent of message not understood in small talk in the dynamic world because they don't have the right context. Okay, of course there's a problem. What's to prevent somebody from writing any of these things, putting it in the context, and then messing up our stack? So, just to recap for a minute, the slots that can break the invariant can only be accessed with the right piece in the context. And now, if we want, what we need to do is we need to protect access to that coordinate. And this reminds us of the object capability model that Mark Miller, the other Mark Miller, has worked on. And so, one way to do it is we could use lexical scoping. This is pretty straightforward. If we have a lexical scope and we write our push pop in it, and we write our SP and contents so they can appear in the slot guard, then this won't work and this won't work because stack invariant won't be accessible outside the scope. But it gets better than that. Notice, without adding public, private, anything new, we've gotten a use of our multiple dimensions to do it. But it gets better. Suppose I have multiple invariants that cut across what you would think of as classes or abstractions. So here's a graph. It's got nodes and edges, and we want that if the edge has its target node set to n, that edge is one of the edge collections in the node. So here's an invariant that the node points to the edge edge points to the node, and here's the one for the other direction as well. Well, we can take each of these, one for the in edges, one for the out edges, make a coordinate, add them to the appropriate slots. So now in edges and source node and target node are guarded by these things as well. And now we've got protection that cuts across abstraction boundaries. And I think this is probably more flexible in Friends. I'm not 100% sure. We could talk about it offline. But what I love about it is it's not a special feature in the model. It just falls out. So one interesting thing is, will lexical scoping run out of gas? Are we going to need something else? Maybe not, maybe. So, to summarize this example, we have reified these invariants as capability. This says objects, it should be coordinates. Visibility of the capability coordinates can be restricted by, say, static nesting. What used to be private is just protected by another dimension. And you could think of this as different subjective views on the objects. If you don't have that invariant in your context, you don't see the hidden slots. You don't see stack pointer contents or those edge things. But if you have it, that puts you in a different context where these other things become visible. So I like to think this model is simple but expressive. Let's talk a little bit about the environment or ways to think about this. So one way to think of this system is a big sea of slots, because they're not contained in objects at all. But the environment can group them for you. And for example, here it's grouped the slots. It's showing you every slot whose receiver is associated with the tree parent object, or tree 1, or stack 2, or stack 1, or stack parent. This is kind of a data structure-y view. So we're dancing with the symmetry. We've put an asymmetry in the way you're seeing this to fit the task at hand. And the environment can give you more information. Like it can say, this slot here, visualize, is connected to the HTML coordinate along the viz dimension. So when I have my context set that way, I will see this slot. And this just shows you some of that stuff. Here's a num to show in the visualize that shows how many stack elements will be shown in the visualization. Connected to receiver is this thing, no assertion checking, and HTML visualization. Or the environment could simplify the view. And I don't care about that for this task. It can just show you that stuff because we've got the information with the dimensions. Or it can show you, I care about visualization, show me the data structures and only the slots connected with visualization. Okay, here's our data structure view again. Now, maybe instead I'm thinking about the assertion checking code in my system. Well, instead, I can tell the environment, no, group the slots this way according to how much assertion checking they do. Because all the dimensions are symmetric in this model. So all I'm doing is I'm picking a different slant on the system, a different angle to approach it with the environment as it lays it out on the screen. Well, this raises an interesting question, because if you think of these things as objects, what are the objects? Are these the objects? Or are these the objects? Are these the objects? Well, this is what I mean when I say we have subjective objects. Because if you think of an object as the collection of slots that are related, in the context, depending on your context and depending on the values of the dimensions, there will be different possible slots that can be found by a message send. And if you want to take sort of the God's eye objective view, it's just a big old sea of slots. So this is where the dancing with symmetry stuff comes in. You see, the space on the system is symmetric. As Harold likes to say, we have broken the tyranny of the dominant decomposition. Copyright Harold Osher. I love that phrase. And, but different tasks, the IDE can give us different subjective views. And that's pretty cool. And in fact, it's probably necessary with this thing. So that's why we talk about harnessing the power of complexity. This is not a model for Emacs and text. We really need help. I guess the fashionable word for this is tooling, but I don't like tools, I like realities. But another rant. Let me talk a little bit about how this thing works. The heart of the language is the dispatch. Now, you're all used to this from standard object-oriented programs. I have a slot specific to sets doing add-all, a general slot for collections. I do an add-all to a set. Well, the most specific slot has to win the dispatch. And this generalizes, in many cases, to multiple dimensions. So I have a slot specific to sets and terse logging, a general one for collections and no logging. But I'm asking for receiver set and logging is terse. So again, the most specific slot wins. No big deal there. Another one that's come up is a slot must match in all of the dimensions. So the inheritance gives us a form of or, and then the different dimensions gives us a form of and. So it's a little bit like and or trees. So here I have a message to a set with no logging. This slot is only for terse logging, so the top slot's got to be the one found by dispatch. So every piece of a guard in a slot has to be satisfied. As I mentioned before, if I have an unguarded dimension, that means don't care. So here where I've got no checks for my assertion, this bottom one says fast checks. The top one doesn't care what the assertion dimension is. The top one can match. What's nice about this rule is it's easy to evolve the system by adding new dimensions. I don't have to go back to every slot when I add a new dimension. I only have to add it to any of the slots that care. By the way, if a slot doesn't have any dimensions in its guard, if it's empty, that's a good old function. Now, here's a really interesting case. Remember how the most specific slot won from before? Well, look at this for a moment. I'm asking for logging set to true, and my receiver is a set. I'm doing my add all. This bottom slot is specific to sets, doesn't care about logging. This top slot is general for collections, but boy, it has that logging true part in it. So which slot's going to win? Which of these two ought to win? Well, yeah? Sorry. It turns out that it seems right to have the match count trump inheritance. So the slot with more matches seems to be a better match than the slot with fewer matches, but they may be more specific. And what we found is as we used the prototype, we tended to define our hierarchies first and add dimensions later, often adding a slot near the top of the hierarchy with the extra dimension. So,
two different slots with the same number of matches.
Okay. That's a new kind of ambiguity. I mean, people who know multiple dispatch are used to this from before, so you can get these ambiguities if the matches are the same number, the same specificity. So here are the rules. The children beat the parents. Their omitted dimensions match anything. And the number of matching dimensions trumps specificity, but every dimension mentioned in the slot must match the context. Yeah?
When you said omitted dimensions match everything, then why didn't you count as two matches in the don't care case? Wasn't the dimension omitted?
When I'm talking about the number of matches, I'm talking about the number of things mentioned in the guard that match. So if one slot has 3 things mentioned in its guard and another one has 2, and there are 1,000 dimensions in the context.
That other match, the other use of the word match, which just does not reject.
Okay. So the benefits of these rules, it's, as I said, we don't seem to need that visitor pattern stuff at all. The system's evolvable, easy to add new dimensions. Dimensions can only apply to part of the space of slots, because if a slot doesn't care, it doesn't even have to mention it. And if it's passed into the context, it gets passed down to whatever it gets called. Seems to be pretty easy to understand, and it reduces to what's familiar. Let's see. How many more minutes do I have?
10.
Oh, great. I have time to do this. Here's another way to visualize the system. It's not quite as tough as solving this puzzle. We think of each role as a dimension in space. So here's 3 space with a dimension for logging that gives us, the vertical coordinates, none, terse, verbose. Same thing here for what's the receiver, different, what we used to think of as objects. Same thing. Now, here, what I'm showing you is the parents can be thought of as living in all the places of their children. Then continuing with this metaphor, what's a slot? Well, a slot occupies a region of the space. So here's a slot for stack parent as the receiver, no assertion checking. Logging is verbose, so it's up here at the top in the front and these right-hand two parts of the cube. It's a pop slot that's going to do logging and popping. Then a message send is thought of as going to a point in the space. So this is the point where there's no assertion checking, logging is verbose, receiver is stack 2, we're doing a pop. And what does the system do? It just runs the closest fitting slot. So that's another way to think of this whole metaphor. We have a sea of slots, they're in a space, slot occupies a volume, message send goes to a place, and it runs the most specific one. Well, I'll show you a demo of the prototype. By the way, here's what's in the prototype. Here's as far as we got till we were defunded in this work. It's 27,000 lines of self and a bunch of cores examples.
Where was this work done at?
This was done at IBM. So let's run this and turn on mirroring. Okay. What I'm showing you here looks like a self object, but it's really every slot whose receiver coordinate is this stack. And if I click on this little box, it wiggles that to show you that's what it is. So here's a simple core stack, and I can push a 1 on here. I can push hello. These are just evaluators. They have code, and I can run it from here. I can push hello. I can pop. Oh, I should have done a do it, not a get it. Sorry. I can pop. There's our hello. I can pop. There's the 1. And I can pop. Whoa! I did one too many pops. Stack underflow. Oh, bad, bad, bad me. Okay. So, gosh, I really want some assertion checking code. Here's just some pre-canned code snippets to get me what I want. Okay, now if you notice, there's this new pop slot that's got basically the code I showed you before. And its receiver is still the same thing. Okay, so now if I do a pop, whoa, what did I do wrong? Oh yeah, what I forgot to do is I forgot to add in that assertion thing to the context. So I have to say, set the assertions dimension to check fast, and now call pop. And now, in fact, I get my error showing up just as I want. Well, that's a pain to remember. So what I really would like is I'd like the environment to help me out. Well, let's try this again. There we go. This is called a simplification morph, which is a terrible name. And what it's going to do is anytime I evaluate code, it's going to add this thing to the context of the evaluation. So now if I just do a plain pop, I get my nice error. But it could do more than that. For example, I could say, I'm used to objects. Can you hide that receiver business? Oh, that looks better. In fact, I'm a novice. I don't know what assertion checking is. So now it can filter what I see so that I've got my good old object-oriented view. Except what happens if I trip over the assertion? Well, maybe I want it to show me that assertion slot again. Or, hey, I'm an expert, show me the whole deal. Now, what's interesting about this, or one thing that's interesting, is I can get this slot. So here's the pop slot. Because remember, the pop is really the thing, and I can say, what's that receiver bound to? Okay, it's this guy. And I can click here and get every slot that's connected to, say, check fast. And that shows me that I've got pop and remove for queues and remove element for B trees. But if I ask for that slot, the interface will indeed preserve the identity, tell me it's the same slot. So we've got a primitive debugger for this thing too, but I'm not going to show that right now. Let's just quit. Go back into the slides, turn off mirroring. There it was. Turn mirroring off. And let's wrap this up. Okay. What, I have about 5 minutes left?
Yeah.
Okay. So this didn't come from nowhere. Very few things do. Randy Smith and I did some thinking about subjective objects. We had a language called US, which was just a thought experiment. I didn't have the named roles. A lot of things weren't as well developed. Harold's been thinking about subject-oriented programming in multiple dimensions for a long time too, but it was static rather than dynamic. It didn't have the symmetries that this has. And of course, Craig and lots of folks have done multi-methods. Craig wrote about a synthesis with objects, but he didn't have the implicitness. And I really think that it's the combination of the implicitness and the multiple dispatch, each of which is an old idea, but I've been very nicely pleased at the synergy, the power of putting them together. There's been some work on context-oriented programming, and as far as we can tell, that work layers things on top of an object model rather than revisiting the basic assumptions. So we think our model is simpler, cleaner, maybe more powerful. Where does the name come from? I'm a big fan of this book called General Semantics by a Polish count named Korzybski. Without going into detail, he talks about how at all stages of perception and thought, we're always looking at things from a particular context or view. And a lot of what we think of as reality is just determined by our perspective at that moment. And of course, here the intervening code can be oblivious, but the perspective matters eventually. Okay, and even object identity is relative in this world, which I love. There's a lot of stuff that we ought to do that I wish, if the project were ever funded again, we would be finishing the debugger, doing all, you can read this slide. It's the usual stuff you need to do once you have the idea. There's some really cool stuff too. So, there's the whole development environment. Now that we have these dimensions, one dimension we could use is novice, intermediate, or expert. And we could filter what you see or what you can change in the IDE by that dimension. Or we could use different dimensions to do sort of meta-oidal stuff and affect the interpreter. I could say, if you find multiple slots, run them all in parallel and give me back a bunch of the results. Or, if it's distribution, where to run the thing. Or we can get rid of, Gilad and I wrote this great paper explaining mirror architectures, which originated in Self. I will say that. And thanks, Gilad, for liking the idea and taking it further. That's great. But Randy always said, well, it's just another way to look at the object. And so if you think of base and meta as just two different perspectives on things, it raises a whole bunch of interesting questions about what other interesting perspectives might there be? So, of course, there could be a dimension that says no side effects allowed. And we could be a dimension that says how much precision we want when you finally get down to the real arithmetic. So let's wind this thing up. The key idea came from thinking that the power of objects comes from having this unstated, ubiquitous context. Object-oriented programming is just procedural programming with one piece of implicit context that affects the meaning of what happens. And once in a while you change it, but mostly you stay in the same context. Okay, well, if one's good, more better. So we tried to come up with the simplest model we could to just extend it. And there's a lot of stuff. The people who like static checking can figure out how to statically check it, et cetera, et cetera. But I just wanted to explore the core of the idea. It's implicit arguments and multiple dispatch. I think I've bored you to death with the benefits. Here's the Three Stooges slide again, which is a good one to leave up on the screen as we take questions. Or me and Mo, Larry, and Curly take questions. Yuck, yuck. So, should I take questions now?
Thanks. Yeah, let's keep going on. We now know that lunch is out there, so let's take one or two questions, and then the rest of the many questions that are probably there.
Sure.
You know, once Dave has something on his plate, make sure he doesn't get a chance to put it into his mouth. Okay, one or two, you pick.
Me? Oh, I didn't see what. I think you had your hand up first, Leo.
So in object-oriented programs, very often there is this one a group of special privileged functions that we call constructors, in the sense that they have a somewhat different context typically than the rest of the functions that you call. How does that work in your model? Is there such a thing as a constructor, or are they just global functions somewhere? Now objects are no longer...
So back in 1986, Randy and I did away with the needless complexity of constructors. That's one of the beauties of a prototype-based world. You have prototypes, you copy them to create objects, you don't construct them. I'm not saying the complexity didn't move to another piece under the carpet, but it's nothing we had to worry about for this case since we started with self. But we're thinking about. Carl, you're going to be interesting.
Oh, thank you.
Not that anyone else wouldn't be.
Okay, yes, right.
I shouldn't have said that.
You go for the nearest slot, right? Now, when you start writing more code and you introduce some more slots, isn't there a big danger that some of the existing code will stop working? Because all of a sudden they'll find these new delicious slots closest and more attractive and just break.
So just a nit, it's not the nearest, it's the best matching one. Okay. But yes, absolutely. So,
new best slots.
So adding new slots to this system is analogous to overriding methods in a class hierarchy, except you have all these dimensions. So maybe it's more complicated and confusing.
This guy here and the guy over there dies. I'm not even on the same path of anything.
Yeah, what I can say is this is the same sort of weak answer someone else gave yesterday. It doesn't seem any worse than the status quo, modulo having multiple dimensions. We need environment support to keep track of the dimensions. The environment can also tell us when we add a slot that's going to shadow other slots in certain circumstances. It hasn't been a real problem for us tinkering around with the prototype and examples. That's all I know.
Well, thanks again.
Okay. Thank you.